Hi students, I am your Nagini ma'am, chemistry mentor. In this section, I am discussing excellent tricks to find optical isomers easily. In this section, I am discussing students optically active isomers, how to find optically inactive isomers, how to find total optical isomers, how to calculate, understanding. So, I am giving the best tricks students. See here, optical isomers. So, if the given compound contains same groups or different groups, understanding, if contains same groups, what are the formulas we have to follow? And next one, if suppose the given compound contains different groups, then what formulas we have to follow to calculate optical isomers? Clear? So now see students here, first one, same groups are there, then what are the formulas students? If different groups are there, second type, different groups. Okay, listen, different groups, same groups. So if same groups are there students in the given compound, what is the same group? In the example I will discuss with students. Okay, now I am giving the tricks. Now I will use these tricks in the examples. Okay, then you can understand easily. Okay, same groups. So if the given compound contains same group students, okay, how to calculate optical isomers? What formulas we have to use? In same group students, again here even number of chiral carbons are there, means one formula, and odd number of chiral carbon atoms are there in the given compound, we have to follow other formula students. Understanding? See here, if even number of chiral carbon atoms are there in the given compound, okay, again it is divided into two types. See here, it is even number of chiral carbons. Okay, even number of chiral carbon atoms are there, means chiral carbon atoms. Okay, even number of chiral carbon atoms are there, means we have to use different formulas. Okay, now I am taking odd number of chiral carbon atoms. See here, second type, odd number of chiral carbon atoms, odd number of chiral carbon atoms. Okay, see here, same groups. So in same groups, two types are there. One is even number of chiral carbon atoms. If the given compound contains even number of chiral carbon. What is chiral carbon? You know already. Chiral carbon means the carbon which is surrounded by the four different groups. Understanding? Four different groups attached to the four different groups attached to same carbon. That carbon is calling as chiral carbon. Okay, chiral carbon or chiral center, stereogenic center, stereo center, asymmetric carbon atom, different names are there. Understanding? Chiral carbon. Okay, that means carbon which is surrounded by the four different groups students. Four different groups attached to the carbon. That carbon is chiral carbon. Okay, now see here, odd number of chiral carbon atoms are there. We have to follow different formulas. Okay, now see here, what are the formulas we have to use? In the even number of chiral carbon atoms case students, even number, we have to how to calculate optically active isomers, optically inactive isomers. Now see here, it is again divided into two types students. See here, this one optically active, this is optically active. How to calculate optically active isomers? Okay, this is optically inactive isomers, optically inactive. Clear? So if suppose the given compound contains even number of chiral carbon atoms, then how many number of optically active isomers are there? How many number of optically inactive isomers are there? And total number of optical isomers how much? Then we can find students. See here, by using the formulas we can easily calculate. See here, optically active isomers. What is the formula? Optically active isomers students, formula 2 power n minus 1. What is the formula? 2 power n minus 1. Okay. Optically inactive isomers. How to calculate? What is the formula students? See here. 2 power n by 2 minus 1. 2 power n by 2 minus 1. This is optically inactive. This is optically active. Optically active compounds means which compound, students? Enantiomers. Optically active compounds are calling as enantiomers, students. Clear? Optically active are, students? Enantiomers. These compounds are calling as enantiomers. Okay. Optically active. Optically inactive compounds are calling as meso compounds. Okay. Meso compounds. So meso compounds are optically inactive because they have plane of symmetry. Understanding? So they are optically inactive. We know that. So optically active isomers formula 2 power n minus 1. Optically inactive 2 power n by 2 minus 1. What about optical isomers? Total optical isomers, how to calculate? Total optical isomers means, what is the formula, students? Total optical isomers. Total optical isomers. How to calculate? Total optical isomers is equals to optically active plus optically inactive isomers, students. Optically active plus optically inactive. Optically active, what is the formula? 2 power n minus 1. Okay, 2 power n minus 1. Optically inactive, 2 power n by 2 minus 1. This is the formula to calculate total optical isomers, students. Understanding? Total optical isomers. Okay na? That this is optically total optical isomers formula, students. Clear? This is total optical isomers. Like this we have to calculate, use this formula. This is optically active, this is optically inactive. Both add, you will get total optically inactive isomers. Clear, students? This is total optically, this one you should add. Clear? Both add, you will get the total optical isomers. This is the case of even number of chiral carbon atoms are there in the given compound. Like this we have to calculate total optical isomers. If suppose the given compound is having odd number of chiral carbon atoms, okay na, how to calculate? What is the formula of optically active? What is the formula of optically inactive? How to calculate total optical isomers? Clear? Now see here, odd number of chiral carbon atoms. So here, if suppose the given compound contains odd number of chiral carbon atoms, students, what is the formula? Optically active, optically inactive. Okay, isomers. Optically active isomers compounds are enantiomers. Already here I discussed. Optically inactive are meso compounds. Okay, optically active compounds, what is the formula, students? Optically active to optically active isomers, to calculate, what is the formula, nana? 2 power n minus 1 minus 2 power n minus 1 whole by 2. This is the formula we have to use to calculate optically active isomers in the case of odd number of chiral carbon atoms. Okay. Next one, optically inactive isomers. How to calculate? What is the formula? 2 power n minus 1 whole by 2. This is the formula we have to use to calculate optically inactive isomers. Okay. Next, how to calculate total optical isomers? Total optical isomers, how to calculate, students? How to calculate total optical isomers? Optically active plus optically inactive isomers. Understanding? Optically active plus optically inactive. Optically active formula, what, students? 2 power n minus 1 minus 2 power n minus 1 by 2. Optically inactive isomer formula 2 power n minus 1 by 2. Both we have to add. This value, this formula, this formula we should add. Then you will get the total optical isomers. Are you following? Total optical isomers, optically active plus optically inactive. Understanding? This two we have to add, nana. This is this one, both formulas we should add. Then 2 power n minus 1 by 2, 2 power n minus 1 by 2, this one minus 2 plus 2 cancel. Final value is 2 power n minus 1. 2 power n minus 1. This is the formula to calculate total optical isomers in the case of odd number of chiral carbon atoms. Clear? Clear, students? This is the formula we should use. Clear? Understanding? This is the case of same groups. Now we are discussing the different groups. See here, different groups are there. If suppose in the given compound different groups are there, what is the formula to calculate optical isomers? We have here, there is no here optically active, optically inactive, students. Only just a simple formula we have to follow, that is 2 power n. Clear? For suppose in the given compound different groups are there, what is the formula? 2 power n. What is n, students? Here number of chiral carbon atoms. Okay, so here already I discussed number of chiral carbon atoms. Understanding? Chiral carbon or chiral center. Understanding? Asymmetric carbon atom, stereo center, stereogenic center, like this different names are there. Okay, clear, students? See here, once again I am repeating. See here, optical isomers. To calculate optical isomer, students, here in the given compound, if same groups are there, we have to use different formulas. Different groups are there, this is the formula. Okay, in same groups, if suppose even number of chiral carbon atoms are there, optically active, optically inactive formulas are there. Total optical isomers means this optically active, optically inactive we should add. Odd number of chiral carbon atoms are there means optically active, this is the formula. Optically inactive, this is the formula. Clear, students? Clear this one? This is the formula, students. We have to use this formula for optically active. Optically inactive, this is the formula. Okay, here optically active 2 power n minus 1. Optically inactive 2 power n by 2 minus 1. Okay, optical isomers, total optical isomers, this plus this one. Okay, this plus this one, this is total optical isomers. This is in the case of different groups. Clear, students? Right. Now we will discuss the example, students. What is same group, what is different groups? Now you can understand. Okay, see here. See this example, HOH, CH3, CH2, CH3. So in this compound, students, this compound just divide into two parts, students. Divide into equal two parts. Okay, now I am dividing like this, two equal parts. Okay, now here see top CH3 group is there, at the bottom CH2 CH3 group is there. Both are different groups now. Methyl ethyl group is there, correct? Different groups are there. Okay, just whatever the given compound is there, just divide into two equal parts. Now you observe left to right or top to bottom. Understanding? So if different groups are there means we have to use different formulas. Same groups there means same groups formulas we have to use. See here, if suppose divide this compound into two equal parts like this, then up here CH3 top, here about bottom CH2 CH3, students. Different groups are there. Different groups are there means what are the formulas, and here how many chiral carbon atoms are there? Here we have different groups. Clear up? Different groups are there. Okay, different groups are there in this compound. Methyl ethyl. Okay, so in the different groups case, how many number of chiral carbons are there? This is the chiral carbon. Are you following? This is the chiral carbon. Chiral carbon only this one. This is chiral carbon. Chiral carbon. This is chiral carbon. Because it is surrounded by four different groups: hydrogen, CH3, OH, CH2, CH3. Hydrogen, methyl, OH. This is ethyl group. Different groups attached to this carbon. This carbon is chiral carbon. Now in this compound only one chiral carbon atom is there. Only one. Understanding? Only one chiral carbon atom is there. Clear up? Only one chiral carbon atom. Now different groups are there. One chiral carbon atom. Different groups there means what is the formula we should use? See here, different groups are there. See here, different groups. Different groups are there means what is the formula to calculate optical isomers? 2 power n. 2 power n formula we have to use, right? Just use this formula 2 power n. Formula 2 power n. N is equals to how much, students? How to calculate total optical isomers? 2 power n formula. 2 power n is equals to how much, Nana? Only one chiral carbon atom is there. N is equals to number of chiral carbons. One carbon atom is there. So 2 power 1. So answer is 2. Total optical isomers how much, students? 2 over. This is total optical isomers in the given compound. Clear? How to calculate? Understood? Now see here this example. This is the chiral carbon. Okay, because it is surrounded by four different groups: H, CH3, OH, COOH. Four different groups are there. Now divide this compound into two parts. This one. Now up CH3, down COOH. Different groups are there. Clear? Different groups are there. So this is also case of different groups. Okay? Different groups are there. Different groups. How many chiral carbon atoms are there? Only one chiral carbon. Okay, n is equals to 1. One chiral carbon atom is there. Different groups of one chiral carbon. What is the formula to calculate total optical isomers, students? How to calculate total optical isomers? Formula what? Total optical isomers is equals to 2 power n. 2 power n, same formula. N is equals to 1. Answer is 2. Clear up? So 2 optical isomers are there for this compound, right? Next one. See this compound. See this compound, students. Divide this compound into two equal parts. Now here I am dividing like this. Okay. Now here this left hand side benzene ring is there. This side what is there, students? CHBr, CH2, CH3. Are you clear? Understanding? This side C6H5 group is there, phenyl group. This is CHBr, CH2CH. Different groups are there. Clear? Different groups are there. So this is also the case of different groups. Understanding? Different groups are there. What is the formula? 2 power n. Total optical isomers is equals to 2 power 1. A 1 chiral carbon. This is the chiral carbon. Bromine, hydrogen, CH2, CH3, this one. Total 4 groups, different groups attached. That's it. Only one chiral carbon is there. This is the chiral carbon. Understanding? This is chiral carbon. Chiral carbon. So n is equals to 1. Only one chiral carbon. 2 power 1, 2. Answer is 2. Total optical isomers. Total optical isomers 2. Clear? Now see this compound, students. Here how many chiral carbon atoms are there? How many chiral carbons are there? This is the chiral carbon, this is the chiral carbon. See here, this is chiral carbon, this is chiral carbon. This chiral carbon, if I take H, CH3, OH, fourth group is this one. Understanding? You have to consider this is the fourth group. 1, 2, 3, 4. 4 different groups attached to this carbon. This is the chiral carbon. Now I am taking this is the chiral carbon, second place. Now here hydrogen, OH, CH3. This is the fourth group, different group. 1, 2, 3. This is the fourth group. Clear? So 4 different groups surrounded by the carbon, students. So that's why it is the chiral carbon. Here n is equals to how much, students? 2. 2 chiral carbon atoms are there. Clear? 2 chiral carbon atoms are there. N is equals to 2. And next one is similar groups are there, different groups are there. See here. So this is the, here see students, chiral carbon atoms are there on the vertical line. See here. Then just you divide this compound horizontally like this. Horizontally. Okay. Horizontally divide this one. Now see here. Top what group is there? HOH, CH3. HOH, CH3. See here, this is, both are similar groups are there. HOH, CH3, HOH, CH3. This is, this group, both are similar groups. Understanding? Similar groups are there. Now this compound divided into 2 equal parts like this. Okay, now we are getting at the top, bottom, both are similar groups. Understanding? Same groups are there. So that's why here same groups are there. In same groups n is equals to 2. 2 yaru even number. Even number of chiral carbon atoms. Understanding? Even number chiral carbon atoms, same groups. Now see here formulas. Same groups are there. Same groups. Okay? Same groups. Even number of chiral carbon atoms. Even number of chiral carbon atoms are there. Means what is the formula to calculate optically active? 2 power n minus 1. Even number. Clear up? Even number 2 power n minus 1. This is 2 power n by 2 minus 1 optically inactive. Total optical isomers, both we have both formulas we should add. Understanding? Optically active plus optically inactive isomers. For both formulas we should add. Okay. Now see here students, just add. First you calculate optically active isomers for this compound. What is the formula, students? Optically active. Optically active isomer formula is 2 power n minus 1. Okay. N is equals to 2. Calculate here. N is equal to 2 means 2 minus 1. Then 2. Total optical active isomers 2. Optically inactive isomers calculate. Optically inactive formula what? 2 power n by 2 minus 1. Then 2 power n by 2. N is equals to 2. 2 by 2 minus 1. 2 cancel. 2 power 1 minus 1. 2 power 0 1. Understanding? Optically inactive 1. Optically active 2. Okay. Then total optical isomers, tell me. Total optical isomers, optically active plus optically inactive isomers. Optically active 2. Optically inactive 1. 2 plus 1, 3. So this 3 is the total optical isomers for this compound. Clear, students? Very easy, students. Very easy. Similar groups are there. Total number of chiral carbons 2 are there. Even number optically active. Are you following? Optically active formula 2 power n minus 1. Optically inactive 2 power n by 2 minus 1. Calculate these two values. Both add. You will get the total optical isomers. Clear up? Clear, students? Now take this one. Take this example, students. Take this one. So divide this compound into 2 equal parts. HOHCH3, HOHCOOH. Both are different groups case. This is the different groups. different groups. N value tell me 2 kada. Number of chiral carbon atoms, this is chiral carbon, this is chiral carbon. HCH3OH, fourth group is this one. This is the chiral carbon. It is attached to 4 different groups, hydrogen, OH, COOH. This is the fourth group. Clear? 2 chiral carbon atoms are there. 2 chiral carbon atoms, N equals to 2. Different groups divided into 2 equal parts. Here this one, these 2 groups are different groups. Understanding? Top or bottom, both are different groups are there. Clear up? Both different groups are there. Different groups, N equals to 2. What is the formula to calculate total optical isomers? 2 power n. Is 2 power n, 2 square. How much students? 4 optical isomers. Total optical isomers, how much students? 4. Clear? Now see here this example. This one also, divide this compound into 2 equal parts like this. Now HOHCH3 top, HOHCH3 at the bottom. Both are similar groups. This is the similar groups case. Understanding how to divide similar groups, how to identify different groups, how to identify, understood similar groups. Okay na? HOHCH3, HOH similar groups. How many chiral carbon atoms are there? This is the chiral carbon atom. This is, now see HCH3OH, this is fourth group. Chiral carbon. This is the chiral carbon. See here, carbon HOH, HOHCH3, HOHCH3. Are you following? So this group similar. Then it is not a chiral carbon. Are you following? This chiral carbon, listen students. This chiral carbon I am saying HOH. This is third group. 1, 2, 3. This is fourth group. See this group same kada. Then similar groups attached means it is not a chiral carbon. Chiral carbon means the carbon which is surrounded by the 4 different groups. But here similar groups attached. It is not a chiral carbon. Okay, chiral carbon. But in the case of 3 similar functional groups, see here 3 same functional groups are there. OH, 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 similar functional groups are there. This is chiral carbon only. Okay, this is chiral carbon only. This is not the chiral carbon. But listen carefully students. Here 3 similar functional groups are there. OH, OH, OH. In this case students, second carbon also we have to consider as a chiral carbon. It is not a chiral carbon, but we have to consider this carbon also as a chiral carbon students. Understanding? Because this configuration and this configurations are different. See here, this configuration, which one students are or yes? Around this carbon atomic number ranking method, tell me. Ranking method. Tell me ranking method. Oxygen higher atomic number group, first priority. Second priority, this carbon. Understanding? Second priority. Third carbon, this one. Fourth one, this one. Hydrogen atom is on the horizontal line. Horizontal line. RS configurations in the last video I discussed students. Once you go through that video, you can understand RNS configurations. Okay. Here I am not discussing. Just directly I am writing students. Hydrogen atom is on the horizontal line. And atomic number ranking. Priority order. Atomic number priority order. 1, 2, 3. 1, 2, 3. 1, 2, 3. It is which direction? Clockwise direction. Hydrogen atom is on the horizontal line, clockwise. Which configuration? It is S configuration. Okay. This carbon is S configuration. Now this carbon also calculate. This carbon, what is the first priority? Oxygen is the first priority. Second priority this carbon. Third priority this one. Fourth priority this one. Hydrogen atom is on the horizontal line. 1, 2, 3. 1, 2, 3. It is a anti-clockwise direction. Anti-clockwise, hydrogen atom is on the horizontal line. Okay. Anti-clockwise horizontal line. Which configuration students? R configuration. Okay. This is R configuration. Now see here, this is S configuration. This is R configuration. This carbon S, this carbon R. Are you following? That means this group S configuration, this group R configuration. That means different configurations groups attached to this carbon. That's why this carbon also we have to consider as a chiral carbon. Clear? Understanding? In the case of 3 similar functional groups, the second carbon also we have to consider as a chiral carbon because it is attached to the different configurations groups. Clear? That's why n is equals to how much, students? N equals to 3. Clear? Similar groups are there. HOHCH3, HOHCH3, N equals to 3. 3 chiral carbons. 1, 2, 3. N equals to 3. This 3 is arrow, odd electron. Odd kada? Odd number of chiral carbons. Odd number. Right? Similar groups, odd number. What is the formula we have to use, students? Similar groups are there. Similar groups, odd number of chiral carbon atoms. What is the formula we have to use? Optically active, this one 2 power n minus 1 minus 2 power n minus 1 by 2, 2 power n minus 1. This is optically inactive. Okay. Now use formula, students. How to calculate? Optically active, tell me. Optically active. What is the formula? 2 power n minus 1 minus 2 power n minus 1 by 2. N is equals to 3 kada, substitute here. N equal to 3. 3 minus 1 minus 2 power 3 minus 1 by 2. 2 power 3 minus 1 means 2 square. Minus 2 power 3 minus 1 by 2, 2 power 2 by 2. Okay, 2 by 2, 1, 2. Then 4 minus 2, you will get 2. Understanding? 2 optically active isomers you will get. Optically inactive, students, optically inactive formula what? 2 power n minus 1 by 2. Then what you will get formula, what you will get value? 2 power n value 3 kada? N value 3. Then 3 minus 1 by 2. 2 power 2 by 2, 1. 2 optically inactive isomers. Okay. Now what is the optically active total optical isomers? Tell me. Optically active plus optically inactive isomers. Optically active 2. Optically inactive also 2. Total 4. Total optical isomers 4. Clear, students? Clear? I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel. Thank you, students.